Okay, so the second topic or second technique that we are going to study this week is called exponential smoothing. All right, so this is a formula for the exponential smoothing. So forecast for the next period ft plus 1. So this is our number that you want to calculate is equal to, we use something called alpha. It's called the smoothing constant. So it's a constant, okay? And yt is observed actual value. And 1 minus alpha times ft is old forecast, the recent forecast, okay? So alpha is basically weight between actual number and the last forecast. And you put some weight, so it can be 50-50, or it can be 60-40, or maybe 90 and 10, something like that, okay? So that's exponential smoothing, all right? So let's look at the example, okay? So this time I'm going to use exponential, exchange rate from, this is Bank of Thailand website. Okay, so we can see, so you can select the date. So let's select from May 1st until recent one, June 23rd. Okay, then you can check the, select the currency. So let's use a US dollar for example. Okay, then we can download as Excel file as usual, so we can use this. So let's see. Okay, here we go. So this is the exchange rate between Thai baht and US dollar from, I think, May 1st. I think the bank was closed, so there's no information from beginning of May until June. Okay, this is buying rate. You know, exchange rate, you have buying rate and selling rate. Let's use the selling rate. Okay, so first we decide what will be the alpha. Okay, so alpha, put like this, alpha. Alpha is equal to, let's use it at 0.7. Okay, then it's going to be you forecast. The first one, you need an actual number. Okay, so this is going to be initial number. It's just a same number, initial number. Okay, initial number. Okay, so exponential smoothing using this formula, all right, is going to be so the day for the next day's forecast for, let's assume that we are May 5th today, May 5th now, okay? So the tomorrow is going to be alpha times actual number of yesterday, right? Plus 1 minus alpha, okay, times forecast of yesterday, okay, and the alpha doesn't change, it's constant, so I have to lock this, okay. Next day, no, sorry. I made a mistake, sorry. So what I need to lock is alpha. Sorry, G4. Okay, so this, you need to lock this one as well. Then okay, so the next day is going to be alpha times actual yesterday plus 1 minus alpha times forecast yesterday. So this exponential smoothing, when you forecast, you use two information. The first information is actual number of yesterday, And the second information, you use the forecasted number of yesterday, all right? So these two numbers you use to forecast the number for exchange rate for the tomorrow, okay? And alpha, put the weight. So this time we put 70% of the actual number and 30% of the forecasted number. So that's what the exponential smoothing is about, okay? So we do the, okay. Okay, so the rest is the same. So we need to calculate error. Error is actual minus forecast, right? You guys already know this. Then you need to know absolute error, right? So ABS. Just take the negative off from the number. And absolute error percentage, right, is equal to absolute error divided by actual. Okay, there you go. Okay, so now we can calculate MAPE, which is just the average number of this percentage error. Okay, so actually these are the percentage, so I just make it to the percent. Okay, all right, so this time we have a MAPE of 0.24, which is very good because you want actually zero error, which is the best one. And it's not even the 1%. So maybe exchange rate doesn't change much every day, so maybe the error is really small, but it's very good. Okay. So this time we used alpha 0.7, and we get this MAPE. So I just copy this, copy and paste as number, paste value. So there's no formula here, right? Just a number. Okay. Then make it percentage. Okay. All right. So how about when we change to the alpha to 0. Let's change to 0.8. Okay. Then everything change. So when it's alpha is 0.8, actually this one changed to 0.3%. All right, here. So it's actually better. How about alpha becomes 0.9? Does it change more? So let's see. So 0.9. So it can actually improve like this. How about alpha is 0.4 this time? 0.4. And that's not good. Okay, like this. So we can compare. So we can change alpha to see which alpha is the best one. All right, because alpha is a constant, it doesn't change. Okay. All right. So that's how you do this exponential smoothing. Right. So this is second assignment. So I just use an US dollar for currency. So I want you to choose any currency you like. You can use, I don't know, Euro, Japanese yen, or Singapore dollar, Chinese yuan, anything, or any currency from this BOT website, because you can choose like many currency here. All right. So I wanted to change. I want to choose a currency and just do the forecasting evaluation using the simple exponential smoothing, the way I just showed you before. And I just want you to try 3 different alpha. You can choose any alpha between 0 to 1. So alpha cannot be more than 1. Alpha cannot be less than 0. Okay. So it has to be 0.1, 0.25, anything. All right. And I want you to select the best one. And I just want you to need to see your interpretation and comment on a result. So for this one, I can say from here, alpha of 0.9 is the best. So the weight for the actual number is more important, maybe I can say, because remember exponential smoothing, it's all about the weights between this is actual number and this is forecast number. So it's just as a matter of the how much weight you put on this and this, right? So in my case, actual number, if you put more weight here, the forecasting gets better. But in some case, maybe the actual number is less important and the forecasting number is more important. So maybe alpha can be small, right? Because alpha, let's say 0.1 to the actual number, 1 minus alpha is going to be 0.9. So 90% is going to be put on the forecasting number. Okay, so that's what the interpretation can be like this. All right, so that's your second assignment for this week. Okay, all right, I hope you enjoy.